I'm going to clutter up the board a little bit, but you're used to that. Here's a circle, and I'm going to start off by assuming that this circle has a radius of 1. Then, if I have a vector from the center to any point on the circle, radial vector to any point on the circle, and let's see, I'm going to label this. Okay, well this vector I'm going to call R. We can project that vector onto the y-axis. We can project that vector onto the x-axis. If this angle is theta, the coordinate at which the vector projects onto the y-axis is r sine theta, and the coordinate at which it projects onto the x-axis is r cosine theta. Okay? Now, that takes care of, if you measure the angle from the positive x-axis around to the vector, you don't have to worry about whether this is positive or negative, whether this is positive or negative. It'll come right out of the calculation. This angle is in the second quadrant. The cosine of any angle in the second quadrant is negative. So if I call this angle 120 degrees, I'm going to get a negative down here, and I'm going to get a positive up here, because that's what we would get for 120 degrees. Okay? These are our definitions of the sine and cosine. Any other definition you have, don't forget it, but this is a definition we use in this course. And when we do vectors, we measure their angles from the positive x-axis and use these. As long as the angle is measured from the positive x-axis, this works. Okay. One thing that follows from this, and you know that the tangent is just the sine divided by the cosine, so that if this angle is theta, and I should have labeled that because that's our premise. Okay. Well, first of all, summarizing what I have here, I'm going to say that Ry equals r sine theta, and Rx equals r cosine theta. It's not a definition in terms of triangles, although it's totally equivalent to what you get when you define triangles, but it goes a little further and gives you a little more power. And from this, we easily, well, from the fact that we have right triangles here, we see that r equals rx squared plus ry squared. And we can also easily verify that the angle is the inverse tangent of ry divided by rx plus, I'll use degrees, but if you're working in radians, of course that's pi radians. If Rx is negative, that might be getting a little hard to read, simply says, well, your arctangent gives you an angle between negative pi and pi, or between negative 90 degrees and positive 90 degrees. You might need to review your trigonometry to understand that, but it's not difficult. If you have, okay, and between negative 90 degrees and positive 90 degrees, Rx is always non-negative. It's either 0, which would be at negative 90 or positive 90 degrees, or it's positive, which is the case for any angle, except 0 or 90, negative 90 or 90. So if you want an angle on this side, well, the angles that you get between, say, 90 degrees and 270 degrees, that is between pi over 2 and 3 pi over 2, those angles are going to be exactly opposite the angles that you get down here. So if Rx is less than 0, you got to switch your angle around by going 180 degrees from that angle. That's why we add 180 degrees if Rx is less than 0. I'm not going to say any more about that, but if anybody has trouble with that, I'll be glad to explain it a little further. Just ask me. I won't use class times. Ask me after class or between classes or something, during office hours. This is everything you need to know to do vectors in this course, pretty much everything. Now, one other thing, though, is we've got this I vector and J vector. I've recommended that you read this from sections in your book where this is introduced. It's simple enough. The I vector is the vector 1, 0. That's a vector 1 unit in this direction, nothing in the y direction. The J vector is 0, 1, vector just in the y direction. So if I had 3i, well, it'd be 3 times this. It'd be 3, 0. If I had 3i plus 4j, well, 4j would be 0, 4. If I add 3, 0 to 0, 4, I get 3, 4. So I get a vector 3 units this way, 4 units this way. So it's a very simple idea, but it's a really convenient notational convention for a lot of the calculations that we're going to end up doing in the near and distant future. See? So that's our scheme for measuring angles. Now I want to talk a little bit about radians and what that means. Oh yeah, well, okay. Clarify one thing. I said this is a unit circle. If this is a unit circle, then r, the magnitude of your r vector is just 1, and this is just sine theta. And that's the way I should have said it here. Okay? Now for any vector, if the radius of the circle is r, then we have r sine theta and r cosine theta, and that's where these things come from. So I kind of said this was a unit circle, and then I sort of forgot that I'd said that. But, okay, now, if the radius of the circle is r, everything I said holds.